This is always fun. All right, we're going live. We're very much live. We are super live. We are live, and we are here direct with everybody. Very happy to be in our meetup. I believe this is officially announced as meetup number 91. If I'm mistaken, if it's meetup number 92, I apologize. But when you get to so many meetups, it just gets a little bit difficult to keep track. A couple of things before we get started. Data on Kubernetes community will be celebrating the DoK Day very, very soon in Los Angeles. We were talking about that earlier, different ways of pronouncing that word. So if you have not signed up already, it's totally free. It's very easy to sign up. We've already got 2,000 people that have signed up. Don't worry, but we have capacity for everybody. All right, no one's going to be left out. Very easy to get involved. We've got a bunch of talks planned for that. We still got a couple of panels that we're going to be telling folks about. We got a big announcement that's coming out tomorrow. No spoilers, not going to tell anybody. We also have on October 6th, next week, we have the DoK Students Day. So if you're more on the beginner side, just getting started out with data on Kubernetes, we'll be having about 30 talks, 25 of which will be given by students, most of whom have never given a talk before. So that's also a very exciting day for us. It's the first time we'll be doing, and definitely not the last, doing a DoK Students Day. So very excited about that too. Now, but for today, we're going to be talking about an operator. Not the first time we've talked about operators. Today, we're going to be talking about the Apache Druid-Operator, but more importantly, with an extremely friendly, intelligent person, works for Data Rills. His name is Adheip Singh. He was also telling me some other names that he has, but we can get into that later. Adheip, it's very nice to have you with us today. Can you just tell us a little bit about who you are, where you're from, and what we're going to learn about today with you?
Thanks, Bart, for the nice intro.
No problem.
My name is Adheip Singh, and I'm currently based in Bengaluru, India. I've been working on to Kubernetes since like 1.3 was released, so pretty familiar in this ecosystem. My current company,
really quickly, if folks don't know, when was version 1.3?
Like I guess 2.5 years back.
Oh, that's pretty good. That's pretty good.
Yeah.
That's pretty like OG, like original, you know, like you have a good amount of experience in. That's cool. Good.
Yeah, it was approximately in 2018, I guess, which when I started with that. I work for Rill Data, which is a Apache Druid managed platform, a SaaS platform for Druid. So my day-to-day role is mostly around Kubernetes, development of the operator in Go, and running basically big data pipelines on Kubernetes. So a lot of stateful sets and data being ran on Kubernetes.
Wow,
and
that's perfect for our community. That's exactly what we want to hear. That is music to my ears. And talking about that, what are some of the challenges of working with getting big data pipelines on Kubernetes? Is it difficult?
Yes, it's extremely challenging and difficult. That's why operators are for solving those problems. Otherwise, you could just simply run Helm and stateful sets. The mainly challenge of running big data is they were not like kind of designed to run on Kubernetes and containers. So you need to kind of build a bridge between what your application wants and what Kubernetes interprets. And you want to build that logic inside. You want to build that logic, right? So it's like Kubernetes does not understand, hey, I'm scaling a Druid pod or a Kafka pod. It just knows I'm scaling a pod. So, but the ways of scaling, the ways of handling certain edge cases are different. So you want to build that application logic inside Kubernetes. So that's where the operator comes in. So it's basically more of reconciling what you want and how can it be done on Kubernetes. So that's where the challenge lies. And plus stateful sets always have their own challenge, and data in different parts of the cloud environment, different zones, and how do you handle all of those stateful set deletions, persistent volume claims. It's like you use different kinds of storage classes when provisioning PVCs, so all of them have their own challenges when you want to run things on scale. So yeah, that's what I've been kind of working on for, I guess, past 1 year with Rill. So it's been great and challenging altogether.
Yeah, very good. So we'll probably be unpacking a little bit as we go on. And like I said, operators is a pretty, solid topic that we've had occur again and again, looking at all the different operators that are out there, seeing, the process of building an operator. Do you have the staff that can dedicate the time that's necessary to do that? How long is it going to take you? What is the value that it's going to be provided? Seeing all this sort of operator ecosystem is interesting. And then also thinking about, if not operators in the future, what might there be? we can get to those questions later. So if you want to share your screen right now, just as a reminder to folks in the audience, feel free to ask questions whenever you want in the chat, and we'll be happy to answer them accordingly.
Yeah, I hope my screen is visible.
It looks great. Yes.
Yeah. So Apache Druid on Kubernetes. So I'll just quickly go with the agenda, what I have for today. So we'll do an intro of what Apache Druid is, what are the how and when to extend Kubernetes, whether I should use a Helm on an operator. So this is one of the most common questions you get asked, and what is the difference between an operator and a controller. Introduction to the Druid operator, then how do you scope the Druid operator, watching namespaces and all that stuff. Then how understanding the Druid CR, like how is this CR scoped off, and then some of the operator's features, like how does it handle orphaned PVCs, how can you scale Druid nodes vertically, volume expansion, what are Kubernetes finalizers, lowering upgrade of Druid nodes. We also have a small kubectl-druid plugin to help with managing the Druid CR. There's also a DudeCase Extension, which kinds of removes the dependency on Zookeeper. So a brief intro about that and something about how we are running Apache Druid and Kubernetes at Rill. So what is Apache Druid? Apache Druid, it's a real-time analytics database designed for fast slice and dice analytics on large data sets. It's columnar, it's OLAP, it's an Apache Foundation project. It's been quite popular in the OLAP query system. And most common use cases are, clickstream analytics, risk fraud analysis, server metric storage. So how basically Druid is designed is that it has like 5 or 6 nodes, and like to run a Druid cluster, you require minimum of 5 nodes, and it has uh, various ways of ingesting data. So it has a lot of connectors. You can ingest Druid data into Druid using Kafka, using HTTP, using S3. So it basically supports real time and batch both. Um, so yeah, so I'll just go through the Druid architecture a bit. And so basically this architecture is what the operator deploys on Kubernetes. So Druid is divided into on a higher level into 3 servers: master, query, and data servers. Uh, it also has external dependencies, which is the metadata store, the Zookeeper, and the deep storage. So deep storage is where all your it's like an object storage where all your data is kept safe. Zookeeper is generally used for leader election and service discovery, whereas metadata storage keeps the record of your metadata. So it can be an SQL or a Postgres. Uh, Middle managers and historicals are the data nodes. So whenever you kind of submit a spec to a Druid cluster to kind of ingest the data, the middle managers are responsible for indexing it. So they kind of run those tasks in real time. You can, as soon as a task spec is submitted, once the ingestion starts, you can query that data. So that's what like Druid is popular for real time. And once that data goes to deep storage, it's like a segment. It's immutable in nature. That segment is pulled onto historical nodes and kept in disk for query. So you can kind of segregate your historical data into hot, cold, and into further tiers. Uh, Routers route your queries to the brokers, and brokers further query either the middle manager or the historical, depending upon where your data is. Uh, Master servers are basically coordinators and overloads. So coordinator handles all the coordination between all the Druid components, and you can also run coordinator and overload inside a single pod. So that's what we have been kind of running along. So yeah, this is the Druid architecture. So now we want to run Druid on Kubernetes, and now the point comes in: when and how can I extend the Kubernetes, and why should I? So in terms of Druid or in terms of any, I'll say, big data systems, they are complex and they were not designed to run on Kubernetes. So you want to make sure that Kubernetes understands application specific knowledge. Kubernetes does not know I'm running a Druid node or I'm running a Druid pod. It just sees everything as a pod or a stateful set or as a deployment. So you want to build a bridge between your what your application understand and what Kubernetes understands. So the operator is basically a reconcile loop. It's basically a state management, which kinds of sees, hey, what is your current state and what is your desired state. So it basically makes a transition between those two. So Kubernetes gives us a lot of options to extend. You can extend by using a custom API server, which is again the API aggregation layer altogether, where you'll have your own API server and your own HCD. So that's it's a very big thing to build out. In terms of Druid, we have a custom resource definition, which is a CRD group version kind. You can use those custom schedulers if you want to have some one of your own scheduling algo in terms of scheduling pods. Admission webhooks, something about admission webhooks. Whenever you kind of do a kubectl get pods, it goes through authentication, authorization, and admission control. So once your request is authenticated, it gets authenticated through your x509 sets on your kube config. Then it gets authorized through RBAC, and then it gets there is an admission controller, right? So you can have two types. There are two types, which is validating and mutating webhooks. So you can have your own validation and mutating webhooks accordingly, and then the request basically goes to the HCD and gets persisted as a manifest. You can also have your own cloud control managers. I guess Google Cloud has its own, AWS has its own, and these are basically, and again, operators, controllers, kind of. I can just submit a manifest to Kubernetes and it will provision a S3 bucket for me. So those kinds of controllers. Custom controllers are basically typical, in shared informers hooked together, and they are usually, any one of your custom use cases. If an image is any image is running on your Kubernetes cluster, you want to validate it, so you'll kind of just scan that image. So something like basic custom controllers. So this is one of the question which even in the community we get asked often, that when should we use a Druid Helm chart or a Druid operator, and what's the difference between those two. So it's not so the answer, I feel, is you need to use both, leverage both of them. Understanding that Helm is basically it's a configuration management for templating large manifests, right? It's just a templating tool. What Helm does not do, it does not maintain the state of the application. So once I've deployed Helm upgrade install, that's it. After that, it's the Kubernetes job to just make the manifest into its native objects. What Helm does have, Helm has a revision number for each Helm chart it deploys, and it is useful for rollbacks. Helm helps in version control of the charts. You can have your own application and your own charts, bundled together. So what the operator does is operator maintains the state of the application, right? Operator is, again, as I said, it's a bridge between Kubernetes and the application. So ideally, you would in this scenario, what you would want is that the CR can be templated out as a Helm chart and can be applied, and the operator can reconcile that CR. And at the same time, you can, if that CR is not appropriate or you want to roll back, you can use Helm to roll back. The operator will again reconcile the state. So this is what we have been using in Rill, and this is like pretty helpful in managing our configurations. So yeah, as I said, both can be leveraged to the best of their use cases. Um, yeah, operator versus controller. So operator is just a word coined to it was a word coined by, I guess, Core OS, as if I remember correctly. And operators can have basically multiple controllers within them. And controller is like the core component, like you have deployment controller, stateful set, endpoint controller. So each Kubernetes object has a controller, because each Kubernetes object has its own definition, which is a group, a version, and a kind. I'll get to those later. So controllers are a core component in the Kubernetes. So if you see this for loop, so basically what a controller does or an operator does, it gets the desired state, which is your custom resource, gets the current state, and then the reconcile loop kinds of make sure the desired and the current is what is interpreted in terms of all your objects deployed. So operators more specifically will watch custom resource definitions, whereas controllers in a generic term can, they can be generic. They can just talk to native Kubernetes object without having a custom resource definition, or you need to apply a manifest. So that's the only differentiator. Apart from that, mostly operators and controllers are same. They can be packaged together, and that's what the Druid operator does.
One thing really quickly. One of our speakers one time said that CRD is his favorite feature on Kubernetes. Do you agree? In yes or no is fine. And if not, what is your favorite feature?
Yeah, so yeah, CRD is of course one of the favorite features. So Kubernetes gives you various, like when you want to start development into Kubernetes, it gives you various options to start, introspecting the code base. You can develop CNI plugins, you can develop API servers, schedulers. So I found that controllers are a fun to start off with, and when you kind of work on controllers, eventually you will of course work on CRDs. So they are the most, I'll say, most easiest way to extend Kubernetes, quick, fast, and plus a lot of frameworks are already available with the Kube Builder and Operator SDK. So yeah, definitely.
Perfect.
So intro to the Druid operator. So what is the Druid operator? It's in Druid-io repo, and it's been almost 2 years since the operator was open sourced. I've been contributing to this operator since I guess it was like 2 weeks old. So I have seen initially, it was using the operator SDK framework, and then it later went to Kube Builder. It's built in Golang. Golang is like, it's like the primary language for when you need to develop and extend Kubernetes, all because all the the frameworks and Kubernetes itself is written in Go, so it kinds of helps in uh, development. Um, so the group version kind, as I was saying, is Druid.apache.org. Version is v1 alpha, and kind is Druid. So what the kind is what the reconcile loop or the operator kinds of looks for. It says like, hey, I have a manifest with kind Druid. I'll now reconcile it. I'll reconcile the state. So it kinds of reads through the manifest and creates all the objects. Um, Group is Druid.apache.org. Same way you have apps v1 slash stateful sets, where your stateful set is the kind and apps is your group and version is v1. So same way you have a custom resource definition according to your use case. Druid operator can enable provisioning, it can management and scaling of complex Druid clusters up to n nodes. So you can keep on adding your Druid nodes, and the operator will keep on creating them and scaling them out. How the operator runs, it just runs as a deployment, and we have Helm support for that installation. To create Druid clusters, operator needs a custom resource which the Druid operator shall reconcile. So it's like CRD, then you create a CR out of, the CRD is the main, CRD is the spec you submit to API extensions. API, which is the primary group to extend Kubernetes extensions. So scoping the Druid operator is something which is like when you want to do a deployment, what do you like? You want the operator to watch a single namespace, or you want the operator to watch multiple namespaces. So as of now, the operator supports to watch single namespace, and it also has another feature known as deny list. So what you can do is, I want to watch all the namespaces, but kube system default ABCD namespace. So the deny list is basically its predicates, which will filter the namespace events from being enqueued into the worker queue. So I'll kind of go over the last line in the diagram. I have a diagram to, just to show how the predicates and the worker queue works. But so the operator is watching multiple namespaces is still in a pull request. Should be merged soon. I have tested it out on my clusters, so looks good to me. Denial list can be used, as I was saying, if you want to exclude certain namespaces, that hey, you can watch everything, but not these namespaces. So you have three options to scope the Druid operator to. So Druid custom resource is what is the CR, right? So you can create multiple CRs, and depending upon how your operator is scoped, it will watch all of them and it will deploy. So Druid operator supports Druid deployment only in a distributed mode. So that means all your historicals, coordinators, overloads will be deployed as separate pods, not into one. Druid has a quick start.sh and all those testing capabilities where you deploy everything in a VM, one VM itself, but the operator does not have any of those modes. It will only deploy it in a distributed mode. So the Druid CR can be scoped into like how the CR is defined is you have key value pairs specific to all nodes and key values common to all nodes. So let's say I want to define image. So image is, let's say, Apache's Druid 0.220, right? That image can be common to all your nodes, all your 5 or 6 nodes you're deploying, or this can be specific to 5 or 6 nodes where you want like, hey, this image should only go to historicals, where I want to have a different image for middle managers, right? So you have the option to scope them out as and when you need. Like it's user friendly, the spec. Um, Druid nodes can be deployed as stateful sets as well as deployment. So initially, the how the operator was written was it was only supporting stateful sets, where everything was deployed as a stateful set. But now you have the option of deploying stateful sets as well as deployments. So what is stateful set in nature is historicals and middle managers. They are stateful set in nature. They need persistence uh, to store the segments and store the data, whereas brokers, coordinators, and routers, they don't need much of a persistence and they can be just used as deployments. So you can uh, you can use either. So you just need to mention kind in your node spec. So once you mention kind, it can be stateful set or a deployment, but the Druid operator defaults to creating stateful set, so you need to explicitly mention deployments. So how does validation happen of the Druid CR? So if I'm submitting a Druid CR, what if my image is not mentioned? And if your image is not mentioned, what will the operator do without an image? So you need to validate the CR which is coming in. So we operator has both. It has a schema-less CRD. It has a schema CRD. The schema-less CRD does internal validation, so it will be validated on the reconcile loop. Whereas on the Kubernetes API level, there is an open API schema, which will kind of validate your CRD to make sure uh, it's appropriate for the operator to reconcile. So yeah, handling of orphaned PVCs. So this was one of the features which we saw at while running the operator at Rill and kind of built this. So uh, a common example is like you kick off ingestion in Druid, right? It's like when you want to load data into Druid, you want a lot of like you provision like 50 or 100 odd middle manager nodes and kind of scale them out to n number. And when you kind of scale middle managers to, let's say, 100 pods, so it's like 100 stateful 100 pods are running, which are 100 replicas of one stateful set is running. And when the ingestion is done, those pods are of no use, so you will kind of scale them down back to one. And in that, whenever a scale down happens, those persistent volume claims which are provisioned by the stateful set, they are orphaned and they are of little or no use. They're just like adding storage costs. So at those kind of in those kind of scenarios, you want them to get cleaned up. So what the operator does, it will see that if in your particular in your CR, if you have defined a middle manager and any of the PVCs are orphaned, it will clean them up. So this feature is optional. Default is set to false. So to enable it, you just need to set it to true. Delete orphan PVC. That's the key, and it's a boolean. So the operator will handle deletion of orphan PVCs. Another feature which we again like running Druid on Kubernetes came up, that scaling Druid nodes vertically. Um, so the historical nodes, it comes up mostly with them, can be scaled horizontally as well as vertically. There are some scenarios, Druid specific scenarios, where you don't want to scale your nodes horizontally and you would like to add more of storage to them. So example is I have historical nodes of size 30 GI, and I want to add more I want to add 20 gigs of more storage to it. So in this kind of scenario, what happens is stateful sets don't allow change in volume claim template. So if you see that you cannot directly edit a stateful set and say, hey, increase in the volume claim templates, the increase from 30 to 50. The stateful set will error out, and Kubernetes does not allow this. So earlier, without this feature, it was a manual intervention, and you had to do your own kind of a hack workaround. So this feature was then, once it was built into the operator, so what the operator does, it performs a cascade deletion of the stateful set and patches the size of the PVCs owned by the stateful set. So once I submit in my CR, once I change it to, let's say, 50 GA from 30 GA, so what the operator will do, it will see that, hey, there is a change in the desired and the current size. So what it will do is it will delete your stateful set. It will not delete it, it will perform a cascade deletion, which means that when your stateful set is deleted, it is just orphaning your persistent volume claims. It is not orphaning your PVCs as well as orphaning your pods. So it is not cleaning up your pods. At that particular point, when there is no stateful set, your pods are still serving requests. They can still serve traffic to your Druid cluster. So on the next reconciliation, the operator, each time on reconciliation, it does create a new stateful set. So it will create it. So this is work in progress, PR. It's almost done. We have been testing it internally at Rill. So it just needs to be merged. So yeah, you'll see that soon in the main branch of the operator. So yeah. So the next thing is Druid-Operator finalizers. So finalizers is, again, it's a Kubernetes concept where you want to run pre-deletion hooks which alert the controller to clean up resources the deleted objects owned. So a typical example of a finalizer is I'm running a pod with the PVC mounted on it, and that pod is owned by a stateful set. So if I delete that PVC, if you see that PVC goes into terminating state but does not get deleted. So if you do a -o YAML of that particular PVC, you will see that in the metadata, there is a deletion time step set, and there is a finalizer also present on that PVC. That means that till the time you don't clean up your stateful set, PVC will not be cleaned because it's being already used by a pod. So same way, what our use case for the operator was, whenever we delete Druid clusters, a large Druid cluster can run like lots and lots of nodes, lots and lots of stateful sets, PVCs. So it's like 50 or 60 PVCs are running, and you delete a Druid cluster, and at that particular point, all your PVCs are orphaned, and only PVCs are left. So what the operator does is it makes sure that whenever you issue a delete to the CR, a deletion timestamp is set, and the operator will make sure it clears the stateful sets, it clears the PVCs, and the whole Druid cluster is cleaned up without leaving any Kubernetes objects uh, pending or fund on your particular namespace. So this feature is default. You can turn it off by setting a flag on your CR, but by default, this is how the operator behaves. Um, Druid-Operator rolling upgrades. This is again a very useful feature which is in the operator. So rolling upgrade in typical terms can be, I want to roll out a new image of Druid. I want to upload, I want to change the common runtime properties. So what happens is Druid operator gives you two options. Either you can upgrade your cluster in parallel, which means that all the nodes will get upgraded at the same time, or you can do a sequential rolling restart or a rolling upgrade in parallel. So what the operator does, as per Druid documentation and as per Druid docs, it's defined that these historical overload, middle manager, indexer, broken coordinator, router, these are the order in which Druid needs to get upgraded. And so the operator will kind of make an array of these all these nodes, and at each iteration it will upgrade these nodes. So operator also waits. It also has a function which is an object fully deployed. So which means that it will always wait for the object to get fully deployed and then move on to the next node. So for example, I'm upgrading historical, and at a particular point, due to ABC reason, the historical pod goes into crashing state. And at that point, I don't want to move to overload middle manager, which will, that same faulty spec can lead to, my whole cluster can go into a bad state. What the operator will do, it will just halt it will just halt at that particular point, and it will wait till a user intervenes and kind of fixes that faulty error in the CR. So that's how the operator does rolling upgrades. So pretty useful rolling upgrades, and we have been using it internally, so haven't seen any issues so far. So yeah, lot of has been talked about the Druid operator and how things are working. So at this point, I'll just like to introduce a certain diagram on how the Druid operator and the controller works. So if you see, as I was saying, right, operator is also a controller. So we have a Druid controller and we have a manager. Manager is so yeah, a manager is basically controller runtime, how it the library which the operator uses underneath. So few projects which the operator is using is KubeBuilder, which was used to scaffold the operator, and KubeBuilder uses controller runtime library to to build out all the reconciliation loop. So it's like, I guess, we are not following all the semantics of KubeBuilder. It's just that the Druid operator is bit it's one of the a complex operator. So we have our own internal client, as well as the upgrade pattern is a bit different from the de facto as per KubeBuilder talks. So yeah, I'll quickly go through the Druid controller. What the first thing is, whenever you create a custom resource, right? As I was mentioning, you have a group version, you have a schema builder, and you do an add to a scheme. So that CRD, right, group version kind, that needs to be it needs to follow a particular scheme of the Kubernetes API. So you kind of register that scheme with the API server, which is done in the manager. So informers are another concept in the controllers, where uh, whenever an operator is making an API call, you don't want it, always to call the kube API, just to list pods, to get pods, to delete stateful sets, a number of things. So Druid informer is basically a cache which the operator, with the basically the controller uses to query. Um, the controller runtime has its own client, which basically reads from the cache, and it can write directly to the API server. There is a watcher and there is a predicates event filtering. So whenever an event comes, it can go through a list of predicates. In the Druid operator specific, we are using the predicate to filter out namespaces. So what the deny list was, so if you're watching all the namespaces, the operator, and you have a deny list for, let's say, cube system and default. And in that particular scenario, you go and apply a CR in default namespaces, though you don't want it to reconcile. So in that case, the operator will kind of just filter it out before sending it into the worker queue. So all items in the worker queue are basically of name and namespace. Name is your CR, and namespace is wherever your whatever the operator is scoped to and is watching. So this the events come to the reconcile loop, which is where I've defined what is the Druid controller. So what the first thing the operator does, it validates the CR, then it creates a list of Druid nodes, each node having a node type. So each node having a node type is basically that historicals is of a node type historical, middle managers are of node type middle managers. So basically it is a map of a string to a node spec, which means your string can be anything. You can have middle manager 1, middle manager 2, middle manager 3. That means it will be like 3 stateful sets, whereas each node type will be of middle manager. So whatever decisions the operator makes is on the basis of the node type. And if you don't have a node type mentioned in your CR, the operator will not reconcile. It will throw an error. Yeah, then the operator, what it does, it creates config maps, service deployments, and all the Kubernetes objects which is needed for the Druid controller to run. So all your common runtime.properties, runtime.properties which are specific to Druid nodes are created as config maps. These config maps are mounted onto Druid pods from where the Druid runs, reads its all its configurations from. Um, the operator also has internal client, which if you go into the operator repo, it has an interface.go where there is a reader and a writer interface. Now there is also an emitter interface to emit metrics and events. So the internal client interface kinds of talks has the client, the SDK client embedded inside it, and which uses works in sync with the SDK to do all the jobs. So yeah, this is just a raw diagram which I had kind of built. So yeah. So yeah, the next thing is kubectl-druid plugin. So this was built due to while working on Druid, it was just a Druid CR can go up to 1500 to 2000 lines of YAML, and whenever you want to make a change, don't want to scroll through that YAML file and make changes uh, which can be a pain, right? Like 2000 lines of YAML scrolling them down. So in those kind of scenarios, what we did was we built a kubectl Druid plugin, and we wanted to, let's say, if I want to scale middle managers to 5, if I want to scale them down up, and I can just use the kubectl Druid plugin to do those operations. I don't need to edit the CR and change the replica counts. So basically, kubectl can be extended to write custom plugins. So the Druid kubectl plugin is simplifying kubectl operations on the Druid CR. You can do update as well as patch operations. So you can update an image, you can patch your nodes, you can list all your nodes, you can list all your CRs, and it's like it has support for 6 to 7 commands. So it's like pretty simple. So so there was this extension, DudeCase extension, which was authored by one of the Druid PMCs, and DudeCase extension was basically Druid uses Zookeeper for service discovery. So once this extension is enabled, Druid you don't need Zookeeper. So what this does is Druid Case extension will use the Kubernetes API server for your node discovery and leader election. Um, what it needs to enable this extension, you need to add certain common runtime.properties, you need to add a few lines, and your service account, Kubernetes service account, will need to have permissions on pods and config maps. So you might need to create a role and role binding. Personally, I haven't tested this on scale, but like on in my POC and stage environments, I've tested this extension, and it seems pretty useful. So there is this example in the operator repo, which is still a pull request. It will merge soon. So those looking forward to test it can always leverage it. Yeah. So Apache Druid and the Druid-Operator at Rill. So at Rill, we are heavily invested into Kubernetes and Kubernetes operators. So we use an extended version of the Druid-Operator. It does pretty much of the heavy loading of running Druid clusters. The operator is cluster scoped, means that it watches all the namespaces, and I have a deny list to kind of seclude whatever you know namespaces which I don't want to use. Um, so we have Rill is a SaaS platform for Druid, so multiple Druid clusters with petabyte of data. Um, Helm is used to template out the CR, so all our custom resources are templated out with Helm, and once applied, operator is responsible for managing the state of the CR and reconciling those. And once if a configuration goes wrong, so we can always use Helm to do a rollback, and the operator will again manage the state. Operator metrics at Rill we emit to Datadog, but there is support coming for operator metrics for Prometheus. So there is a /metrics endpoint on the operator, which will give you default operator metrics, which can about how the worker queue performance is, all the Go GC stuff. So that can be used for monitoring as of now. So this is some of my. I just pinned out these learnings in the past few years. I've kind of experienced out. So stateful sets takeaways. So on deletion of a stateful set, PVCs don't get cleaned up. This is something which I have been talking about, and the operator will use. It will make sure that those PVCs are cleaned up by using the delete orphan PVC flag. PVCs can be expanded directly by editing, patching the PVC object. So if I want to scale my PVC from 30 to 50 GI, it can be done, but there is a prerequisite to it. Your storage class must support volume expansion. If your storage classes are not supporting volume expansion, uh, PVCs can't be expanded. If using local SSDs on Kubernetes, cluster autoscaler won't support scaling of the nodes. So we had tried out local SSDs at certain points, but CA cannot scale them. So local SSDs, this is a pinpoint to be noted when anyone is trying to use local SSDs. Cascade deletion of stateful set, I use it pretty often, and whenever you do a cascade deletion, pods are orphaned, and pods will still continue to serve requests. It's just that you need to recreate that stateful set. Deleting a PVC referenced by a pod directly will not be deleted, and the finalizers shall come into play. So I had previously just talked about that whenever you can try to delete a PVC, the finalizers will block it from it will go into a terminating state, but it will not delete. So the stateful set will need to be deleted first. So that's what the Druid-Operator finalizers do. Stateful sets do ordered pod termination. If I'm running 10 replicas of a stateful set, so they will be named as my pod name hyphen 0, 1, 2, 3. And when I'm doing a rolling upgrade, that means the stateful sets will be ruled out in a fashion from 10, 9, 8, 7, 6. So they'll go in this order. So it's an ordered pod termination. Um, Whenever you try to update a stateful set, like if you want to, let's say, update labels for stateful set, the Kubernetes API server will throw out an error. So apart from pod management policy and pod spec, the same stateful set cannot be updated. So you need to do a workaround to get that particular stateful set updated. So yeah, these are the key takeaways from the stateful sets, and this is my presentation. Over to you, Bart.
All right. Very, very good. Very complete. Considering the technical challenges there, but very well laid out in different parts. Now, a couple of things that I want to know, just for starters, because we always like to do a little bit of comparing and contrasting. We look at the use of Apache Spark, for example, we see that being used in probably more cases than we see with Apache Druid. Why is that? And what is it that Apache Druid perhaps offers in those more niche use cases that Spark doesn't?
Yeah. So this is like more of a big data and a data engineering question. So whatever in my knowledge, I'll try to answer it.
It's all good. No, of course, just based on your experience. Yeah.
Yeah. So Spark is batch processing, whereas Druid is more of a real time and real time and batch both. So you can kind of ingest data through Spark in Druid. So that's kind of a pipeline which can be built. Regarding Druid's Druid-Operator, it's like it was recently released. Like it's been since it's still gaining. It's still gaining. People are still kind of still on the way of trying to use it, trying to adopt it. So hopefully this will kind of push more Druid deployments onto Kubernetes, if that was your question.
No, that's great. That's great. Just because let's like, when we talk about, if we're talking about, Pulsar versus Kafka, you got like the Kafka people, the Pulsar people, and, they start fighting each other and disagreeing, things like that. Yeah. No, but I think a lot of it just comes down to what is it that you're looking to do? What are your objectives? And then based on that, what's going to be the best way to line up? In terms of the developments that you've seen as someone who's been working with Kubernetes since you said version 1 point what?
1.3.
Okay. In terms of the changes that you've seen, the evolution, the development, the growth, what do you feel like Kubernetes is becoming friendlier to data, or that's still going to be a major challenge for the next few years?
Yeah, that's an interesting question. So when we say bringing big data to Kubernetes, right? That's the ideal, word, like the sentence to portray. Um, it's I'll still say like the it's like the queue builder and the controller runtime have pretty much matured in a way to develop operators, and like with all the scaffolding coming in with the, like I was saying, like the manager and adding schemes. Like if you see initially how controllers were written was you had to literally write down enqueue and dequeue functions on the worker queue to and then your informers and shared informers used to get hooked in, then event handlers used to be. So that kind of all that logic is now put inside controller runtime, and it's pretty much easy to build operators and kind of do all the custom all the custom logic which you want to build. Specifically for big data, I still feel that there are certain things which can be improved, like local SSDs don't support cluster autoscaler. Uh, some things to do with Farrell volumes, and there are a lot of things which still can be improved there. So but yeah, like with the maturity of queue builder and controller runtime, things are becoming much more easier to uh, build operators, so that we can just focus on our more business logic, which is specifically running Apache Druid on Kubernetes rather than hooking in informers, worker queues, and handling all those Kubernetes specific things.
Very good. So, we kind of touch on this in different areas, but one of the things we ask a lot of speakers, we try to ask all of our speakers is, and particularly someone that's seen the full range of challenges, is that we look at one thing is what is running data on Kubernetes? How do you run data on Kubernetes? But then the other question is why do it? And so there are different reasons. And so one of the ones is to have, one stack for everything, kind of like one stack to rule them all, to not have things in different places. Some will also argue for different reasons, the security of certain kinds of data, that's for financial or healthcare, things like that, or government. There are different ways of looking at it. But going back to the question of is Kubernetes ready for running stateful workloads? And if not, what are the reasons that are stopping that? Is it a talent question? Is it a cost question? Is it a technology question? What do you think is the primary thing that's stopping more organizations from running stateful workloads on Kubernetes?
Yeah, so of course, I'll be a bit biased towards Kubernetes before answering this. Um, so it's like Kubernetes is, of course, it's matured in a way that I guess most of the security concerns can be taken care of if you have proper security context and all your network policies in a managed in a proper way. Um, what I feel can be a pain is that though we are kind of building operators, controllers to simplify certain things, but they also add a level of complexity. So it's like okay, I just learned Helm, and now it's like, oh, I need to even use operator, and I need to package the operator with Helm. So it just kinds of builds and builds over it. But at the end of the day, if you try to see what you're benefiting from such things, is a huge gain. And I believe that this running all the big data pipelines on Kubernetes is a bit complex, but it in the long run is easier once you try to understand that literally your scaling is one of the best things which I've seen. You can just do hey replicas to 3 to 4, and the pods come up pretty much fast, and they're able to serve requests. The same things if you see on VMs might take a bit of time. So those are the things which I feel is that's why and plus at Rill it's like we are 100% on Kubernetes. So uh, we don't want to have some stacks running on VM, some on Kubernetes. uh, yeah, and plus the talent and the cost definitely add on it. It's a niche, I'll say. It's a niche domain, and it's more of a depth than a breadth domain when it comes to writing controllers and operators. So
No, I think
good
those are
for
all,
me.
yeah, I think those are all very good points. And as you said, is that while for some folks it might be a little bit challenging right now, you've really got to be thinking this in a long-term way. Considering that, for example, with just the what you mentioned about stateful sets, is that stateful sets are now, I think, about 5 years old in terms of when they arrived on the scene for Kubernetes. I think it was around 2015, 2016. And there's some debate as to whether or not they've achieved the impact that they were designed to have. I'm just thinking about the future. Do you imagine that there are going to be more, kind of managed data services specifically for Kubernetes? What kind of features do you think we might be able to anticipate based on the kind of things that are going on right now?
Yeah. So I'm not. I haven't like looked into where the Kubernetes stateful sets development or the KEPs are going into, but something which I'll definitely like to have is handling of persistent volume claims in a much more easier way. Like doing cascade deletions and hacking our way towards getting things upgraded. Of course, Kubernetes has a certain if if stateful sets are not allowing us to do certain things, that's there because of a reason. It's not like it was just built out. But
Yeah.
the point is, like, for our use cases or some edge use cases, Druid needs to perform those tasks, and they don't have any effect on the application. So it's like, that's where it kinds of you want to make sure that things go in a certain fashion. So yeah, that's it from, I guess.
No, that's good. That's good. Once again, we're not,
Yeah.
we're not gonna quote you on this and say, well, Adheip told us that this is how it's gonna happen. Don't worry, we're not here to do that. But the thing is, we just want to get these conversations out in the open, and also as a practitioner, I want to know, in your particular case, as someone who is, we can kind of say, has probably learned how to do this the hard way, what have been things that have been helpful for you along the way to be able to navigate the challenges of running, big data pipelines on Kubernetes?
Yeah. So the first thing was to get, like if anybody wants to start understanding this domain, I'll say go to the sample controller repo on Kubernetes, which will help you get started on how controllers work. Not jump directly towards the SDKs, because there are certain times when you want to, like, you really need to know that how the informers and the queues are working together. So yeah, that's pretty much helpful. Running big data on Kubernetes, it's a very fun, I'll say, way to it has its own charm of running these things. Uh, so there are a lot of operators. I'll say try to just start looking into the operators code base. Spark has its own. Streamzy for Kafka is there. Banzai Cloud operators are there. See the Druid-Operator. Try to get into the community, and yeah, you can easily get started into then running data on Kubernetes, and good grasp of basics of stateful sets and how Kubernetes creates pods, deployments, and how you can extend Kubernetes. All the things, I guess, which I explained should be good to start through Helm versus operators.
Follow
And
Adheip's advice. It's very simple.
yeah,
The easiest way
just
to do it.
follow
I
me.
mean,
That's it.
no, but really as well too. Like, we've got, this is meetup number 91. I had to check because sometimes we cancel one and we have to jump ahead and we come back and we do another one. And I've never seen slides that are so clear regarding all the different steps. So I really think this is a wonderful gift for different folks, because a lot of times it's like, okay, trial and error, but you really put things in order. And so I really appreciate that, because we have different kinds of practitioners in our community. Some people have more experience than others. Some people learn in different ways. But I think this is really well laid out. That being said, can I get you to stop sharing your screen really quickly so I can share mine?
Sure.
So while we were talking, we have, as always, our partner in crime, Angel, who's lurking in the background in the shadows. Let me know when you can see my screen.
Yes, I can.
So he created this wonderful drawing while you were talking, and trying to cover all the different sorts of things. And he even drew a druid where it says Druid-Operator, because we were conversing in the background. So anyway, just a nice depiction for us as a way to remember all the different things that you touched on. There were a lot of different things that were covered here. I hope if anybody from Apache is watching this, you definitely need to hire Adheip as a trainer, because but seriously, very well explained, and particularly for a lot of concepts that are overwhelming for a lot of folks. I really appreciate the way in which you explain things. So that being said, if people want to check you out, follow you in social media, or know more about the company where you're working at, anywhere they should go in particular?
Yeah, you can ping me on LinkedIn anytime.
Okay.
Yeah, that's it.
Keep that in mind. Hope to see you in person at some point, whether it's in Spain, the United States, in Bengaluru, not Bangalore. Say it correctly like the local people do. There are 8 million people who live there. I looked it up. It's like I said, 8 million people. Maybe it's more or less. It's just an estimate. But learn how to say things, kind of the right way. A little bit goes a long way. Adheip, shukriya. How do I say that in Punjabi, just so I can get that too?
Yeah, it's like Tanwad.
Oh, Tanvad. So it's completely different. Okay, so it's not like
Yeah.
okay, that's cool. So so Tanvad. So I learned that today. We all learned something. We learned a ton about Apache Druid, but it's nice to end with some cultural notes as well. Thank you very much for your time today. I hope we will see you in the future. And folks, if you haven't signed up for DoK Day and KubeCon, DoK Students Day, check that out. Contact Adheip on LinkedIn. See all the cool stuff they're doing at Rill Data. You have a great day. Take care.
Thank you. Thank you, Bart.
Cheers.
Have a
Bye,
good-
everybody.